Okay, so we just take a screwdriver right here, a little Phillips screwdriver. We're going to pull these little screws out here, undo these. There's only 3 screws that hold the vacuum pod on. Pull those off. And there's a little clip right down here that holds the linkage together. We're going to pop that off. That comes off. Try and save those little clips. Sometimes they come in new kits, sometimes they don't. And here is the vacuum diaphragm right here. This is what actuates the secondaries. If we look right here, there's a little cork gasket. That's where the vacuum passes through from inside the carburetor. Remember I said how these work. Vacuum secondaries are real simple how they work. There is a siphon tube. In fact, this is an earlier model carburetor. If we look down inside right here, we should be able to see right there, there is a vacuum tube right inside there. That is an angle cut tube right here. That is a tube that's sticking out of the body that's cut at an angle. So as air passes over that, it siphons through it. It comes through the body of the carb and comes out right here, right on this vacuum port on the side right here, right there. And there's a gasket that goes on that, and it draws the air out of here. And the spring pressure on here is how much it allows or disallows the diaphragm to move up and down, which brings the secondaries in and out. It's really a simple little process. So they're really not vacuum secondaries, they're more of a siphon secondary, and it works off air velocity through the primaries here, not off vacuum signals like a lot of people think. The next thing we want to check for wear or anything like that is the throttle linkages right here. The throttle linkages, this is where your throttle pedal is attached to, and you constantly have a return spring pressure pulling on it here, and you're constantly pulling against it when you're activating the throttle. And what it's doing is it wears into the aluminum base plate right here. So sometimes these things get a little play in them. This one's nice and tight. You can jiggle them a little bit. It's okay, like sometimes the secondaries, we can move this up and down. Actually quite tight. We'll look on this side right here. If we look right here, you'll probably see just a little bit of movement. That's acceptable. Nothing wrong with that little bit of movement. A lot of basic carburetors have that. When you get into the really trick carburetors like the HP series, there's some carburetors by Quick Fuel Technologies, things like that, some of the Demon carburetors, things like that, where they have billet throttle bodies, they put Teflon bushings in there so you get no slop. And what can happen with that slop right there, this is directly, it's a direct open port into the plenum of the intake manifold. Well, air can get in there. When you get air in there, you got a vacuum leak. Vacuum leaks make erratic idles, up and down all the time, depending on where this is. So when they wear out real bad, this is acceptable. This is not too bad for this type of carburetor, because that's kind of normal. You pick one off the shelf, it'll look just like this. There is a kit, though, that you can get. Right here, several companies make these. This is a throttle shaft bushing kit. And what you can do is they give you a ream, they give you everything to do this, and you can take the throttle shafts out, ream it, press in one of these little bronze bushings right here and rebush it so it's a nice, smooth, tight fit. No air gets in there, no vacuum leaks. But this is acceptable. This isn't something I'd recommend if you haven't done carburetors before. If you're experienced with them, this is okay to do. If you're not, I'd say bring it to a shop and let someone that knows what they're doing use these. I just bought a kit to show you how they come here, and that's how a kit comes when you purchase that. Let me show you another cool tool here. This is one we use here in the shop. It's made by Moroso. It's a power valve checker. We talked about power valves earlier and how they go out. You know, you pop through the carburetor. If you don't have a power valve saver, the pressure coming back up for the carburetor pops that little diaphragm. Sometimes they're really hard to tell if they work or not because you really can't see inside there to see the rubber diaphragm that's hidden under this little metal area right there. So really the only way to check them is with a checker like this. What this little gadget does, it's all made out of billet aluminum. It's O-ringed. We have 2 sets of O-rings in there. We can take a power valve, put the little O-ring back where it's supposed to go. We can screw the power valve into this little guy. Just make it finger tight. Put the lid back on. And we can see the valve right there. Here's the valve, and we can see the spring movement right there. That holds it in place. Real simple. We just take a little vacuum pump, plug this on here like so, and if we watch that spring, if it works, we're going to see it move. See that spring move? That was it right there. I just let the pressure out. If we watch again, I'm going to put some vacuum to it. If the diaphragm was popped, it wouldn't be able to draw that spring. It'd just draw air through it and it wouldn't move it. But I'm going to put a little vacuum to it and watch that spring move. Here we go. And see it holding? It's holding. It's a good power valve. Nothing wrong with that one. So in a pinch, you could reuse this one. When you buy them in a kit, I suggest you just put new ones in anyway. But if you're just doing a backyard rebuild, or you just want to check one, or you think you have a problem with one, or you don't have a tester, you could save these other ones like this. Sometimes I do that. I throw them in a bin marked with what the number is on it, if it's a 2.5 or a 4.5 or a 6.5, 8.5, 10.5, all that kind of stuff, what the rating is on it, and I can use them for testing later if I'm not sure if one's working. I can just try another one and say, ah, here we go. Or another thing that comes in handy for is if I'm not, if I'm having a little trouble with the power valve opening too soon, and this is a 6.5, I can pop an 8.5 in there or a 4.5, go up or down a notch, and see if it helps the car run a little bit better. So it's handy to keep these little things around. If they're popped, chuck it. Don't keep old parts around. If it's broken, it's like a pen with no ink or a pencil with no lead. Don't say broken parts, chuck it. It'll just haunt you later. All right, the next thing we need to do to tear this thing down, we're down to the main body right here, is get the little squirter out of here. We've talked about that before. That's where the accelerator pump squirts the fuel through right in here. And you can see it right there. It's just a Phillips screwdriver. I'm going to loosen it out, pull it out, just pop straight up, and that's a squirter. If you look at it, the screw itself is tapered, and fuel passes right by the screw and comes out these little holes right here. You can see two little holes. That's what shoots the stream of gas jets as the accelerator pump is pushed. There's also a number on here. It's a number 31. That tells the size of the holes right here. The larger the number, the larger the holes. The smaller the number, the smaller the holes. So if you need a larger squirt of fuel, if you're still getting a lean spot in your carburetor, you can change things like this out. Pretty much if you go any bigger than like a 35 or somewhere's up there, you can change the accelerator pump to a 50 cc pump. These right here, this is a 30 cc pump that's on this one. It's a standard size, but you can certainly go to the larger 50 cc and get a larger squirt of fuel. But that would be like for a really large cubic inch engine pulling a heavy load right off the line. Normal situations, basic small blocks, most basic big blocks, don't need anything like that. Squirter with this size right here is pretty adequate. Want you to understand one thing. Don't flip the carburetor over, because right inside here where we took that off, there is a needle valve inside there. So we're going to flip I'm going to put my hand here, I'm going to flip the carburetor over, and out's going to pop this needle valve. There it is right there. And it was facing straight down. It was pointing down inside the carburetor. What that does is it doesn't allow fuel to drain back in. When the accelerator pump activates, it pushes the little guy up and it lets fuel come out. So don't lose that. That sits up underneath here, sits down inside there. So what we're going to do now, we're going to flip this over. That's where that little tool comes in handy, a little stand right there. We're going to take the base plate off. Real simple. Just pop off all the screws out of here. There's little shorties. I'll flip these out. Okay, and the base plate should come right off here. I'll just give it a little tug, and up and off it comes. Of course, all these screws are going to fall out when I turn it upside down. That's okay. That's all right. So this is the base plate of the carburetor right here. And this is, you can see where the linkages work. And of course, the secondaries don't open because it's not a mechanical secondary. This is where the vacuum actuator actuates this right here. We can see our vacuum ports right here. This one right here is manifold vacuum, which takes a signal right here, right underneath the butterflies, and that's the one that goes to like an automatic transmission or a vacuum gauge. That's your full manifold vacuum. The ported vacuum would be up on the side of the carburetor, up on the, in fact, here it is right here on the jet plate right here. It's up above the plates. It's right there. So this one right here has it down below, so that's manifold vacuum. If we look in here, I'm going to show you a little thing that on carburetors here. Get a little pointer. If we look down inside here, you can see little slots, little teeny slots right here. And those little slots, that's the idle circuits. So if you notice when we open up the butterflies, it creeps off those slots. When it's closed, it's back on those slots. Those slots are what controls the idle. So when you're adjusting the air-fuel mixture screws on the jet plates right here, and you're pulling them out, which richens it, all these are, by the way, is just a needle and seat. So when you pull it out, it richens it. When you put it in, it leans it out. All that's controlling are those little teeny slots. So a lot of guys say, oh, I richened up your carburetor, I backed these out a little bit. That just richens up an idle. It didn't have anything to do with main jets. The only way to richen up a carburetor is on the main circuit is to change the main jets. These were 72s. We'd have to go to a 74 or a 76. And by the way, when you're rejetting a carburetor, one size makes almost no difference. There's about a 4%, slightly less than a 4% difference between each jet size. The rule of thumb is if you're changing jets and you want to see a difference in the way the motor runs, go up 4 jet sizes. So if this was a 70, go to a 74. If they're 72s, go to 76s. You want a 4-step jump just to get a difference, to feel a difference. If that doesn't do enough, go another 2 or 4 steps, and then take it from there. Then start backing back, and so you can see what the difference is. And a lot of people don't understand that, when you're jetting a carburetor, you need to let it run a little while, so you can get a reading on the car. I mean, you have to have the car running for a little while to see how it's going to react, what the exhaust pipe color is going to look like. When you're on the throttle, you need to observe things. Is there black smoke coming out the exhaust? Black smoke is gasoline, it's carbon. If there's blue smoke, it's oil. If there's white smoke, it's steam. You need to look at little things like that. If you're getting a lot of black smoke, that's telling you got too much fuel on hard throttle. It's probably jetted a little too rich. But certainly by changing the idle mixture screws, this is one right here, that is not going to rejet the carburetor, and it's not going to rich or lean anything except at an idle, because this is only controlling that little teeny tip right there is all this is controlling, and it controls the fuel and air that's going to this little teeny slot right down inside here, those little teeny slits. That's it. That's the idle circuit. There is nothing more on that. Let me show you one quick thing here that I have. I've got different spark plugs right here. Well, I'll show you this. We'll show these a little bit later too, but I want to lay these out right here because a lot of people want to know, hey, how do I know if my car is too rich or if it's too lean? And the spark plugs tell the whole story right here. The color of them. Remember I just said black smoke is carbon. Well, when you get black smoke, it turns the spark plugs black. And you can certainly see that that's black and sooty. It's really bad. There's almost no put it on a contrast to my hand right there. It's completely black. That's because the fuel in there is not getting warm enough. It's not burning very good. It's too rich. This can be because of the idle circuit's too rich. Could be because the main jets are too rich. That's why I say you gotta run the car normally for a while and see what the spark plugs look like. When we go to one that's been burning too lean, this is what can happen. I don't know if you can see that real good, put it on a contrast in my hand. This was so lean, it burnt the electrode off. It completely melted the electrode. Anytime you lean out an engine, you decrease the fuel and increase the oxygen content. It's just like a cutting torch. You turn the acetylene on, it's a cold flame. You turn the oxygen to it, the flame turns bright blue and hot. And the more acetylene you put to it, then the more oxygen you put to it, the hotter it gets. Same thing with inside of an engine. You put fuel, you put air, it takes a certain amount of fuel and air, like a 13-to-1 ratio right in there, 13.5-to-1 air-fuel ratio to get a normal clean burn. 14.5-to-1 air-fuel ratio, and that's a economy burn. 12.5, 13-to-1 right in there, that's kind of a rich side, which we like on performance vehicles. But when you start really leaning them down, 15-to-1, 16, stuff like that, 17-to-1, this is what happens. It gets so hot inside there, it just melts things down. You can melt the pistons down, you can melt rings, you can do all kinds of things. So it's real important that you know where you're jetted at and if you're too lean or too rich, and that's all dictated by the main jets right here. This is what one should look like normally right here. This isn't too bad of a burn. It's got a little, this engine right here had a little ring problem. You can see it's a little wet looking, it's a little oily right there. The mixture of this, the air-fuel mixture was okay, but it had a little bit of oiling on there. Could have been from an external drip on the engine or possibly a little bit of oil problem on the inside, and that might be why it's a little shiny right there. I just grabbed a handful of these just to give us some comparisons. This isn't a bad looking burn right here. This one right here, it's kind of a medium brown color. It's not certainly black, it's a little medium brown, and it's not white. When you're leaned out, they will turn white. This is one that was leaned out right here. And that was actually run for about, 200 or 300 miles. And in a performance vehicle, that might be a couple of weekends. And it was burning white hot. This thing was leaned out too far, and actually what happened was it had a clogged up main jet is what happened. So it was running really lean, almost white hot. You don't want that. Let me give you two extremes right here, just to kind of fill you in on running too rich and too lean. Too rich, when you're dumping fuel down the carburetor, you get what you call cylinder washdown. And cylinder washdown means when a piston's going up and down in the cylinder, the only thing that's making a ring seal is the layer of oil that's sealing the ring against the cylinder wall. Fuel, when it's unburnt, put it this way, if I took this screwdriver right here and I dipped it in oil, and then I took it over and dipped it in gasoline, guess what happened to the oil? It's gone. The gasoline acts as a solvent and removes the oil. Well, same thing inside your motor. Every time that piston goes down, the crankshaft grabs a handful of oil and the piston goes up and the crank throws oil up into the cylinder wall. When the piston comes down, if it's too rich and you got liquid fuel inside there, it washes the cylinders down. You lose a ring seal. In fact, you can score the cylinders really bad. It's really hard on a motor. It's what we call cylinder washdown. And a quick way to find out if you have that, other than the engine's going to be running poor and you're going to be burning your eyes because it's puking out raw fuel out the back, You can pull the dipstick out and smell the oil, and the oil will smell like gasoline because you're actually washing raw gas right past the rings. That's not good. It's just as hard on a motor doing that as it is running it lean, where it's so hot, everything's running white hot, you know, like this one right here, running white hot, and you can melt the pistons down. So it's pretty imperative that your carburetor's jetted correctly and working correctly so you don't either burn the motor up or wash it down and score the cylinders. Okay, so we talked about running rich and running lean and how we control that by the jet sizes and stuff. It's another lean condition you can run into, and we talked about this with carburetors that are mounted, you know, forward on race cars that launch really hard. I mean, we're, you know, talking 1 second, sub 1 second, 60-foot times. That puts so much inertia when you take off. All the fuel runs to the back bowls of the carburetors, you know, the back of the bowls. What's happening is the front of the carburetor, this would be the front right here, all the fuel in that bowl rushes against here, right against the main jets. That's okay, because we're drawing through the main jets. What happens on the back side, though, is all the fuel runs to the back of the bowl, and it runs away from the main jets. Because after all, you know, the plate is on here, just like so, and the main jets are down at the bottom down here. So with the bowl on here, all the fuel runs away from the jets, you know, so the fuel's getting away from there. So there's a thing we can do to prevent getting lean under really hard accelerations is jet extensions. This is just a little jet extension right here. And what that does, you can screw the main jet in here, then you take this jet extension and it screws right in here like this. What that does, it extends the jet, so even though the fuel is back towards the back of the carburetor, it still puts the jet submerged in the fuel. It brings it closer to where the fuel's shoved up against the back of the bowl. These are just called jet extensions. There's little plastic tubes you can stick on the jets also that extend it back where it siphons out of the bottom of the bowl. But little brass ones like this are kind of nice too. But that prevents leaning out on hard acceleration. And like I say, without these, some people just take the carburetor and they mount it sideways. There's some disadvantages of that too because the linkages are kind of quirky, they're stiff and hard, so sometimes it's better just to have the carburetor mounted forwards. And of course on a single carbureted system, it's hard to have one mounted sideways because the manifolds don't accept it that way. But on tunnel rams, you know, we have one right here. Here's a little street tunnel ram right here. This has forward mounted carburetors, just because this right here is just a street motor. It's nothing that wild. It's something you'd see in a hot rod. It's a little 400 horse motor, nothing fancy, maybe 425 horse, nothing fancy. So for acceleration on something like that, no big deal. It's the jets. You're not gonna slosh the gas to the back that hard on street tires or anything. But on a real hardcore race motor where you got slicks and a car's launching you with 2 Gs or 3 Gs of force and you're shoved in the seat, all the fuel runs to the back of the car when you launch. Sometimes it's good to mount carburetor sideways. So the next thing I want to show you is on the base plate right here. You know, we talked about power valves earlier and the importance of power valves and selecting the right ones, and also an inherent problem that they had on early carburetors, that if you pop through the carburetor, or what they call spitting or coughing, which can happen for 2 reasons. One, because you're too lean. Like for instance, if the accelerator pump's not working, where you give it the throttle and you don't get that squirt of fuel, you will pop through the carburetor from a lean pop. Another way to do it that's pretty common is in the ignition, where you get spark in a cylinder that has the intake valve open. It'll cough right back on up the carburetor and spit. When that happens, when it goes pow back through the carburetor, all that pressure in there has to go someplace, and it does. It goes right on out the carburetor. But usually the throttle plates are closed or they're slightly open, and that still builds up a lot of pressure inside the motor and underneath the carburetor. So what happens is it'll pop that little diaphragm inside the power valve. And I talked about that earlier, that it will pop these little guys. Okay, well there is a power valve saver that you can put in there, and this one has one. If we look right here, you can see there's a little shiny little doodad put right inside there. That right there is a power valve saver kit that's put on. They're only about $9 or $10 from your local retailer. They're easy to put in. They supply you with a drill, and basically it's just a little captured check ball. So what happens is on the bottom of this port right here, which is right there, that's where it takes its air from, right there. So on the bottom side, when this is mounted to the intake manifold, it's drawing its vacuum through here. That's the signal coming up through there that's signaling the power valve to open and close. When you build up pressure, pow! The air comes up through there, goes right on the power valve, and pops the diaphragm, and it's gone. Then you just start dumping fuel all over the place, and the engine won't idle. It's all coffee and spitting, and it's terrible. That little check ball, what it does when the pressure comes in, it jams the check ball up there and stops the pressure from reaching the power valve. The cool thing is all the modern carburetors, all the aftermarket ones, all the new Holleys and stuff, they have one of these already installed. So really the power valve problem of yesteryear is long gone. You don't have that problem anymore. If you have an earlier carburetor and you're going to do a rebuild on it, go down and spend the money. Like I say, 10 or 12 bucks, even if it was 14 or 15 bucks. Who cares? Because a power valve, These cost about that much right there. So in what you save and the pain in the ass of having to take the carburetor back off, tear it all apart, dump fuel all over the place, change a power valve in there, money was well spent when you rebuilt it to put $15 and about 5 minutes worth of labor to drill that out, and you simply put it in there and push it on in and you're done. You put it together, instant power valve saver. Now you don't have that problem anymore. It's worth doing. Make sure you do it on yours if you don't already have one in there. Okay, the next aspect of this, we're going to get down to getting the gaskets off here. Now remember before I said I like to put a little oil on these things. If you have the factory style gaskets in your kit, make sure you oil these so they come off easy. If we have any luck, these might just peel off. Yeah, there we go, baby. That's the way it goes. It's coming right off like that. I only left a little piece there and I was able to get that off. I'll tell you, it's hell when you get the factory ones and they shred and it leaves all the shreds on there. It's a real pain in the butt to get those things off. I'm sure you're going to run into that with some of the carburetors you might end up doing, because from the factory, they don't oil the gaskets, and boy, they stick. Yeah, this came off pretty good. Didn't leave too much on there. Got a little bit. You can kind of see some of the shiny there where I've oiled it in the past, because it is a bear to get these off sometimes. We're getting lucky here. Let's see if we can keep the luck going here. I'll pick this one off right here. Oh yeah, that's the way I like them to come off, just like that. That's beautiful. We're probably not going to get so lucky on this one. I have a hunch that this one's just going to stick and tear, and oh yeah, there we go. This is going to be a fun one. This is going to be one of them scrapers. This is how you can see it just left gasket material right on there. Of course, it didn't leave anything on here. We got lucky, so we only have one gasket area here to scrape. This one's nice and clean. Came right off of that. But on here, you can see as I peel the gasket up, it's just shredding in half. We can't even really get it off. It's just tearing. So the only way you can get around that is take a razor blade and scrape and scrape and scrape and clean. And when you're done, use a little carburetor cleaner and keep scraping. Let me tell you a little quick thing about carburetor cleaner. I have some right here. I see people spraying, carburetors and stuff. They'll spray it and clean little things, and they're spraying their fingers and stuff like that. This is some pretty nasty stuff, especially if you're using the good stuff like this stuff right here. This is B12 Chem Tool. It's probably the best carburetor cleaner there is out there, because it takes the dirt and everything off right now. There are some cheaper ones that are diluted. This stuff works. I wouldn't be spraying your fingers, and especially not in your eyes or anything like that, and don't do it in a confined area, especially if you did what I told you and you're doing it on your kitchen table and you got the terry cloth laid out and you're laying everything out. Don't spray this. This will eat the Formica tops right off your kitchen table. It'll discolor wood. It'll take the nice oil finish right off Mom's nice oak table. Don't use this stuff inside the house at all. Take it outside. Best thing to do is set it down in a nice outside ventilated area, spray it. Don't get it on your skin. This is toxic stuff, and you really don't want it on your skin and soaking up and getting in your body. Just take some precautionary things, some basic common sense, and be safe about it, and you won't have any problems. We'll get to cleaning this gasket right here, and we'll come back when we have everything done, and we'll get ready to put this stuff back together. All right, well, I've got everything cleaned up, just like you should do, and I said with the carburetor cleaner. It helps you have an air hose around, too. I've already gone through and taken all the little fuel circuits right here and air circuits, and I've blown them all out just with a little bit of air. Make sure when you do this, you point this stuff away from you, because if there's any clogs in there or anything like that, it'll blow it right in your eyes. I wear prescription glasses, so I tend to always have a safety glasses on, but if you don't, wear some safety glasses or something, because a little piece of dirt in there with 100 or more pounds of air pressure behind it, and you go blowing a circuit out, you can blow it right up in your eyes. But it's a good idea. Go ahead and blow everything out. Make sure all the circuitry is clean in there and everything. What I've done is I want to show you something here. We talked about this earlier, about the idle restrictors inside here and idle circuits and things like that. These are the low idle bleeds right here, these little teeny guys inside here. We talked about the 3310 carburetor. This was a modified 3310 that we've started with, and it already had the rear jet plate put in and a quick change kit and a couple other goodies put in. The 3310 has been designed for, as I said earlier, for the 396 Chevelles, the late 60s 396 Chevelles. With that, there's almost 400 cubic inches. So on a 350 engine or a 300 cubic inch like a Ford 302 or a Chevy 350 or a Chevy 302, any of those types of motors, these tend to idle a little bit rich that's basically because of the small holes right here in the low idle air bleeds, okay? So what you can do is take a numbered drill right here, which I've already done. I've taken a numbered drill bit that was about 3/1000ths larger than what the actual hole size was in here, and you just simply hand drill it. You put it in here, and I've already done it so it'll slip in quite nicely. But you just hand drill it little by little, and that opens up those little air bleeds inside there, and it pulls it out. When you're done, take a little bit of air and blow it out. And what that does, that opens the air bleeds up to let a little bit more air in at an idle, which leans the idle circuit out. Some of the big carburetors have that problem when you have a big carburetor on a milder, smaller cubic inch motor. On the opposite end of that though, sometimes you'll put this carburetor on, like say, a big block, and you need a little bit more fuel at an idle. Well, on the primary jet plates on these things, and on engines or on carburetors that have four-way idle circuits, they'll also have this on the secondary jet plates. But if we look right here, I put an arrow right here. These are the idle feed circuits right inside right here. Basically, this is a jet plate. So from the center down, this is one side of the car, this is the other side of the car. It feeds both sides of the manifold. So everything on this side is basically the same as this side right here. Pretty much basically, as far as idle circuits and emulsifying tubes and stuff like that. This is where air and fuel gets mixed together at idles and things like that. You know, the power valve goes in here. You got the little power valve circuits where the fuel gets let through the power valves. There's a little teeny hole on each side right there. That's where the power valve goes. This little hole right here, if we flip it over, you can see it's got a little hole down here and a well that comes up. Well, when the float bowl is attached on there and it has the accelerator pump, if we look right there, that's where the accelerator pump, when it pumps fuel, pumps through that little guy right there. It comes up, squirts through here, and squirts out of the squirters inside the carburetor. So that's that circuit right there. Main jets, little things like that. Well, we come in here, and these are the idle bleeds right here. This is where fuel gets collected to feed the engine for an idle. Now, on a larger cubic inch engine, these need to be enlarged. On smaller engines, these can be restricted. It's easier to enlarge them, though. What we do is we take a number drill, go on inside there, and we drill these about 1/1000th of an inch at a time larger. So it's just a little bit at a time. You certainly don't want to enlarge these too much, or you'll screw up the idle circuit and you'll be flooding the engine out at an idle, and they're a real pain in the butt to put restrictors inside there. But on large cubic inch engines, that's where we can go inside and drill them out and make it idle a little bit richer without getting inside anything else in the carburetor. That's where we control that at. So to richen the idle, we increase those. To lean the idle, we go back and we increase the size of these little guys right out here, the outer ones out here. Okay, now being that this is a modified 3310, it has a rear jet plate. But because we're not doing a typical 3310, I wanted to show you what a metering plate looked like. This is another body of a 3310 carburetor, and this is a metering plate right here. And I've taken one out, and this is what they look like. So when you don't have a rear jet plate, this is what it looks like. And basically, it just mounts right to the body of the carburetor. And what it does, instead of having jets that control the amount of fuel going into the carburetor, this has little orifices at the bottom down here, right down here. And that's basically the jet size, and this meters the fuel, kind of like a set of jets, but it meters it and sends it to the right places, and this is what's inside of them right there. Little different circuits and stuff like that send it to the correct places and through the emulsifiers and all the little places it needs to go. The reason they do these is the lesser expensive carburetors, it's less expensive to build this little plate and pop it on than it is to have a jet plate with jets and a power valve and all that kind of stuff. So it saves you money when you purchase a carburetor like a 3310 or a 600 vacuum secondary. They will all have these types of metering plates. The only problem is, like I say, they're not adjustable, so we tend to put the jet plates on and have the jets to be able to recalibrate the carburetor for air-fuel mixtures. All right, so we're ready to start doing the assembly here on this. We've got everything cleaned up. We're going to basically start by attaching the base plate here to the body. And what we want to do first is get the gaskets out. And in the gasket kits, I want to show you something here. These are the base plate gaskets. And I have them stacked up together simply to show you that they all look alike from one to the other, except the size of the holes in here. If it was a 500 CFM or a 450 CFM 4-barrel, it might use the little gasket right here. If we look inside, there's another gasket that's a little bit larger, and then a larger one yet for like the 750 vacuum secondaries. You really need to be critical on this, because if you mix one up, you can have a serious problem if you don't check things. If you put the small gasket on here, what will happen is these holes right here are smaller than the butterflies or the throttle plates on here. So when you go giving it the throttle, they get in here and they bind, and the poor carburetor will stick at like half throttle or full throttle, and you'll not know why. And you go to give it the gas, and the thing will take off on you, and it'll bind against the gasket in here. So you want to be sure you've got the right size. This one uses the largest one, so we're going to use this one right here, and we'll simply drop that on there. Take the base plate. I'll find the front of the carburetor here. Choke horn shows the front of the carburetor. Linkage goes on the driver's side. drop it in place, and we simply take all the screws and drop them in. And you just want to snug them up. You don't want to over tighten them. And when you tighten them up, you just want to do it in a cross pattern. Don't cinch one down and then this one, you'll warp this plate. So just take a screwdriver, just give it like this, and just give them all just a little bit where they're just snug. And go across each other. Okay, those are nice and snug right there. And while we're on this right here, I want to show you, we didn't take this off, but I just want to show you this in case you ever encounter this. On the throttle linkage right here, there's a little plastic cam. What that plastic cam does is it actuates the accelerator pump. When we move this, you can watch this accelerator pump linkage right here move as the linkage is turned. That's the little cam on here that does that. Well, there's many different types of these and different aggressiveness. You can get some that are more aggressive and some that aren't aggressive. This is what the little plastic cam looks like. For most carburetor tuning, for most basic performance motors, you probably won't mess with this too much, but I want to show you anyway, just so you know what it is in case you ever run into it. I mean, that's the purpose you bought this series, is to learn stuff, so I'm going to teach you. This plastic cam right here is the cam actuator for the accelerator pump. It has 2 holes. Some of them have 3, and they are numbered. If you look real good, there's a 1 right there next to that hole, and there's a 2 right there next to that hole. These designate the aggressiveness of the cam. And basically, it's a little horseshoe shape, as you can see here, and it slips over the linkage, and it's real simple to take on and off. There's a screw, set screw right here that holds it, right there. We can screw it out and remove it, pop a new one in there and change it, or simply change the position of it. Basically, what the numbers mean is, number 1 means it activates the accelerator pump sooner and gets full advantage of the cam, meaning it's a more aggressive cam when it's on number 1. That's good for an engine that idles a little bit low, 600, 800 RPM, something like that. So you get the actuation of the accelerator pump right off of an idle. On engines that idle higher, like 1,000, 1,100, 1,200 RPM, sometimes you want to go to number 2 or number 3. And what that does is it backs the cam off. So actually you lose part of the cam movement. That way it lets a little air in first, then actuates the accelerator pump. And that just basically tunes the motor for different idle RPMs and stuff like that. But basically, it's just the aggressiveness of the cam that you can change and alter by changing the area of what screw hole it's through. But that's all that is right there. We didn't remove it here simply because this carburetor was working perfectly as it was before, and it was pretty well set up just the way it was. Now we're going to work on the primary jet plate. We cleaned out the circuits in here, blew them out, used some carburetor cleaner. We're going to put the jets back in. These are the main jets right here. This was jetted pretty well correctly for what we wanted, so all we're doing is rebuilding his carburetors. We're going to put the same jets back in, put those in. We're going to give them a little snug. Try not to over tighten these. I have seen jets get stuck, and they're a bear to get out when they get stuck, and they are soft. And if you're trying to use a screwdriver and you get a screwdriver in here, make sure it's the correct size, because if it's not and you rip these, you'll shred one side, and boy, you'll play hell getting them back out or wrecking them when you put them in. They only need to be snug. They don't need to be torqued down to 100 foot-pounds or anything. Just give them in, give them a little snug. Next one, give it a little snug, and that's good. That's all it takes. Next week, we're going to put the power valve in. Now, these are a little tricky. You want to be careful with these. We're going to take a power valve. This is a new one right here. Put the gasket on. Now, if you notice, though, the gasket sits fine like that, but when I turn it this way, gasket falls down. This is common, okay? So what we want to do is leave it faced up like this. We're going to take the block plate right here, the jet plate. We're going to feed it straight on up in like this. That way the gasket stays seated where it's supposed to be seated. Bring it on up in. That's that right there. And we'll give that a little cinch with a wrench. A little bit later, we'll just a snug, and that's all it takes. But the gasket is seated nice and round. If we tried doing it this way, the gasket would have dropped down, and boy, it'll leak fuel all over the place, and you wonder where it leaked from. Just make sure you do it in a vertical position like that, and you'll eliminate that gasket problem. Okay, the next step here, we're going to take the primary float bowl here, and we're going to put the accelerator pump and everything back in. The accelerator pump has a little valve, a little rubber valve. Some have a check ball inside there, right down inside here. Sometimes just a check ball. Most of them use a little flapper valve. So we just put that, I put a little dab of oil on there just to help it slide in. I'm just going to put it in the center hole there and push it into place. And that's in right there. What that does is when the accelerator pump pushes up and the linkage pushes up on this thing, it doesn't just push fuel back into the float bowl right here. It forces it through this little hole. You can probably see the little hole right there. That's the hole that meters it right on through the jet plate and up through the squirters. If it didn't have this check valve in here, fuel would just be passing up and down, back and forth. It wouldn't go where it's supposed to go. So we have a little spring right here. It's going to go in there. This is a 30 cc accelerator pump. That's what this one requires. And we just take the linkage, pop it on. That's pretty much all there is to it. We just drop the little screws back in and just snug them down a little bit. That's all it takes. Don't have to over tighten. Okay, that's all tight right there. Next thing we need to put in here, we have the float inside here. It's just flopping around. Of course, we've cleaned it all out and everything. We're going to put in the needle and seat. This right here is the needle and seat assembly. This controls the amount of fuel going inside the carburetor inlet, on the inlet feed there. And basically what it is, I'll push it up here. You can see there's a little needle inside right there and a seat. And what that does, it pushes up. So what happens is the float comes up as it rises up, it pushes on that, closes that off, and doesn't allow fuel to come in anymore. So the float controls it. When you've used the amount of fuel inside the carburetor, the float drops, it lets fuel flow back in, fuel pump pushes it in, and it fills it back up and closes it. When you're under full throttle and you're using, flowing a lot of fuel through the carburetor, this thing just sits wide open and just flowing fuel inside there. So we need to change this. What happens to these are pretty sensitive to dirt, and what will happen is a piece of dirt will get stuck inside there. It'll try and close off. The float will come up and try and close it, but it can't because the dirt's in there. It doesn't make a good seat. What will happen is the float will fill up all the way, and that's when you start noticing gas coming out of the one of the vent tubes right here. It'll start puking up out, and that's a telltale sign right there that the needle and seat's not working. On older carburetors, sometimes these stick, and you'll see like an old timer come up and take a screwdriver and go, I can get that to work, and they tap on a float bowl and get that carburetor to work. What they're doing is sometimes these will stick a little bit from sitting for 6 months or a year or something like that to get a little powdery, and by tapping on it, goes and loosens it, lets it drop again. The carburetor works. It's kind of an old timer trick there. Usually it's dirt that sticks in that makes the fuel overflow though. These are real simple. You want to put a little dab of oil around the O-ring right here so it slips in easier. Just drop it in and just thread it on in. It's that simple. We have the nut right here. As you can see, it's got a slot kind of cut in it, and if you look at the needle and seat right here, it's also slotted. So this just drops on. I'm going to put it on here. We're going to tighten it in a little bit. Once we get it down, we can turn this upside down here, and if you watch as I turn this, you're going to see the float start to rise up. See it rising up? You want it just about level as a starting place. I'd rather have it slightly low than slightly high. If it's slightly high, you might flood the motor out and get fuel all over the place. You end up with a fire, you can burn the car up or anything like that. Slightly low is better than slightly high on that. So we're gonna bring it to about halfway right there, okay? And when we're done, we're gonna take a gasket. The large gasket goes on the bottom. Then we put the nut back on. And we put a small gasket up on top. And then the locking screw. And that seals gasoline from coming out of the needle and seat. We're going to leave that finger tight right now because we're not done with this up to this point. Okay, next we're going to take the secondary jet plate right here and we're going to put the jets back in this. All right, next on the hit list here, we're going to take the secondary diaphragm assembly right here, the dash pot. This was our original diaphragm that was in there. This actuates the secondaries. It had a rip in it. And this is what we're looking for right here, stuff like this. This is what was wrong with this carburetor. This thing got ripped probably when it got put in, or maybe someone messed with it one time or something, and the diaphragm got ripped, so that's why this carburetor wasn't working real good. So we found the culprit to the problem that we had. So we're going to take a new diaphragm and pop it in there. There's a couple things that you need to know about this. I took it apart between scenes here to save a little bit of time, and what's inside here, there's a little check ball that goes in here. That drops inside that hole. There's only one hole it can drop in because the other four are threaded. That's what goes in there, and that lets air only go one way, not the other. Let's vacuum work it and nothing else. So we're going to take the new diaphragm right here. We're going to drop it in, and we're going to line it up. And there are two holes on one side. If we look at this right here, there are 4 slots on either side. This one has a slot here and a hole to seal that little check ball up. That's where the air passes through to go through this port right here, which is the vacuum port that transfers air from the body of the carburetor into the secondary diaphragm here. So we want to be sure this is put on correctly and that is definitely sealing that, and that the check ball is in there or it won't work correctly. Next thing we have are springs. This has the quick change kit put on it, but there are many different types of springs. We were using a brown spring in this one because we wanted the secondaries to open up at a particular time. But they're not always just tall to short right here. We have all of them, not all of them, but some of them right here. This one's a little yellow, this one's brown, there's purple ones, there's silver ones, this is a gray one. It doesn't mean the bigger one is stiffer. This little short guy right here is really stiff. This one's really slinky, so is this one. This one's got a different tension on it, and they use different tensions at different times. It's that spring tension right there that controls the opening rate of when the secondaries are going to open on this diaphragm right here. So by selecting different springs out of a spring kit, you can tune your secondaries for when they come in. So we're going to reuse the one that we had. We're going to put this baby back together and put the lid back on. We can put the lid on without this. This is the beauty of this particular one right here, is we don't have to have the spring in it while we're putting this together. Okay, that's in. Now we're going to take the lid. Now remember, this has the quick change kit right here, so we only put 2 screws in. Here's the lid right here. We're going to attach the spring right to the lid. It goes on just like this. Snap that in place. That kind of holds it in. I'll take it here and drop this right on there. This makes life much easier. These things are a pain in the butt to put together when you don't have this lid. When it's just a normal factory top, they're real fun. Boy, trust me. So I just put the screws in here. We're going to tighten this up right here, and this will be together. Okay, that's tight. Now we've got to take a little gasket, and if we look right here, you can see a little well right there. That's where it's indented right there. We have these little cork gaskets that come in the kit right here, and one side has stickum on it. So we can drop it inside there, and that holds the gasket in place right there. It's got a little sticky on it. That way it won't fall out, because you've got to try and get it up against the body right here, and they're notorious for falling out. So make sure you use the right one. It's got a little sticky on it. We're going to put it over the linkage right here. Bring it right up in here. And we're going to put the mounting screws right back in and reattach it to the body here. This right here is all on and tight right there. So that's on. Now we've got to put the little clip back on. We have a little C-clip right here to hold it back onto the linkage, the throttle linkage. Snap that on. Sometimes those are fun on your fingers. There we go. Okay, now that's on. That'll activate. So when the primaries are open, now this little vacuum, that's the vacuum pot right there. That'll activate the secondary springs right there. Now we'll move on to the idle circuit adjusting screws, the air fuel mixture screws. That's these little guys right here. We've cleaned these. That's the little needle screws. What we're going to do is there is air and fuel inside here that these are controlling. So there are little teeny cork gaskets that go inside here. They just push in place, just like so. There will be one on this side right here. We take it and drop it in, push it in like so. Take one of the air fuel mixture, the air bleed screws right there, drop it in, and we'll take a little screwdriver and spin her on in there. We do this to both sides. And be careful that you don't cross thread these. Just start them off nice and easy. Get them in there. You'll feel it start to thread in, and that's fine. Now on these, what we want to do, just for a starting point, is run them all the way in. Don't cinch them down. You'll mess up the seat on them, the little tapered seat. Just cinch them where they stop. This one just stopped right there. And then back it off. There's a half a turn. There's 1 full turn. There's a half a turn. 1.5 turns back out. Okay, we're going to do the same thing over here. We're going to screw it all the way in. Get it to where it seats. Now we're going to seat it down in and then back it back out 1.5 turns. Now a lot of people, I think I've mentioned this before, a lot of people think that you just set these. You just screw them all in, turn them out 2.5 turns or 1.5 turns, and the carburetor's set. Nothing could be farther from the truth. How does the factory know that this carburetor is going to go on an engine that would support 2.5 turns out of air fuel mixture? I mean, does that mean that on a 289 Ford that 2.5 turns works out? It's going to work on the same thing as a 460? When you're talking about feeding less than 300 cubic inches on 2.5 turns, and now that's supposed to work on a 460 cubic inch motor. So it doesn't work that way. It works on idle vacuum and idle speed. And what we're doing is just backing them out 1.5 turns just to give us a starting point. That way we know it's open enough to flow enough fuel and air to sustain an idle on an average motor. So I've bottomed it in. There's a half a turn. There's 1 full turn. There's another half, that gives us a starting point. If you go a little more, a little less, okay, we're not doing brain surgery here, okay? One of the last things we need to do in the body was down in here, we had the squirter area. So we need to, that's where the accelerator pump squirts through right there. Here's the little squirter. There is a little gasket that goes in there. First thing we need to do though is take that little needle. There's that little needle. We need to drop it down inside here. So we're going to take it, and it's down inside the little hole right there now. That helps regulate it, and we'll take this little guy right here. There's a little tapered gasket like this. It's kind of a bent gasket. We're going to put that on there. Drop it in the top of the squirter, and it's beveled up on top right there. We drop it right down in place. You see it's got a notch in the backside right here. It's also notched in here. We're just going to drop it down in there. Get it started with our fingers. I know it's hard to see with my big hand in there, but you'll see it in a second here as soon as I get it started. There it is right there. It's in place. And we'll take this and get it cinched down. And that's good to go right there. Now we're ready for the jet plate right here. We have everything in here. It's the air-fuel mixture screws right here, the main jets, the power valve, and right up here we have a little anti-slosh deflector for the vent tube. And what that does is, as the car's bouncing around, any fuel that gets sloshed around in there, it just diverts it away from the vent tube so it can't just shoot up the vent tube. So we're going to take a gasket right here. This is a bowl gasket. I'm going to drop it right on here. And these do have a top side and a bottom side. And the way you can tell that, the bottom side has a hole right down here. This is that well right there, and a hole down here for the accelerator pump. And we need to have the hole there. If you flip it upside down, they won't even fit. They have all these pegs on here to help hold everything in place and help hold the gasket in place. We'll put that on there like so. And that side will cinch down once we get ready to put it on. We have this side right here. This side takes the other gasket. Now these are directional. If we try and put it on backwards, it won't fit. There's a pin right here that won't allow it to fit. There's no hole there for that dowel pin. So if we flip it over, there is a hole there for that dowel pin, and there's a hole here for this dowel pin. So that pretty much eliminates you putting the gasket on backwards, and it obviously won't go on upside down because there's a big hole there for the power valve. It won't allow you to do that. So what will happen is we're going to take this, the jets face forward. This is the primary one right here. We're going to drop it on here. Hopefully the gasket doesn't fall off like that. And it did, and sometimes you'll run into that. Gasket will fall off, no big deal. Just put it back in place. These are the nitrile gaskets. They're kind of flimsy. They don't hold in place real well, so you can just hold it like this. That's on right there. And we'll take the float bowl. We're going to take the float bowl. Now the only trick to putting the float bowl on is you got to watch this linkage right here. This is the accelerator pump. Okay, and when we put this on, you just want to be sure that the linkage is below this linkage right here. A lot of people put them on. They'll make the mistake of dropping it on. They'll put the screws in, tighten it up, and then they'll find out, oh man, I can't get it underneath my linkage. So just set it under. There it is right there. We're going to take the screws, hold that with your hand. Now these screws right here have gaskets that go on them. So what we have, there's 4 little gaskets. We're going to drop one on each one right here. We'll just stick one on just like this. Drop it up in there. That keeps the fuel from leaking out the mounting screws there. We'll take another one. Drop it on, and we'll do that to all these. Give that a last little cinch right there, and that's it. Front whole part of the carburetor is on. You don't need to over tighten these, just cinch them down about 5 pounds of pressure or so. It doesn't take that much. You don't need to really cinch them down or anything like that. That's plenty tight, just a good snug. I'm going to flip it around right here. Look on the back side. Now again, this was a modified 3310, so we do have a rear jet plate. There's our jets. We put those in earlier. We snugged them down. Again, don't over tighten them. Try not to strip them out because that's the fuel flow that goes in there. Besides, if you strip them out, you're going to get little pieces and particles of soft material, the brass that it's made out of. It'll get inside there. It goes through the carburetor, either clogs it up or goes down in your motor and does a nice little score on your cylinders. You don't need stuff like that going on. So same as the front. We're just going to pop the gaskets on. This one will go on this way here. That's on like that. The rear does not have a power valve, so that's okay. We'll flip it over here. These only go on one way. And what I want to show you too is I showed you the anti-sloshing plate on the front. Some bowls have those in them that are on the metering blocks or jet plates that look like this. The other one's just a short little piece of plastic. This is just an anti-slosh plate. All it does is, so fuel sloshing around in there has to come up, go through here, then up the vent tube. say like a four-wheel drive or a hard accelerating car or a car that's sloshing around, it just prevents the fuel from puking up through here. Okay, we're ready to put the bowl on. Before we put the bowl on, I want to show you something real quick here though. This was a center hung float bowl. Right here is a side hung float. And the difference is, you can see pretty plainly right here, this one moves up and down this way, this one moves up and down from the side. And that's why we're talking about carburetors that launch off the line. You might have a center hung like this. The back one, when you take off, goes whee, goes on up and can flood the carburetor out. Or shut the needle in the seat off and not get fuel. You know, you can go either way on that. So, you know, the front and rear bowls can move quite a bit and cause, you know, a fuel increase or a fuel decrease. Side ones, though, aren't affected so much by forward and backward acceleration. Unless the carburetor is going like this, you won't get movement in there. So, and the cars don't usually move this way, they go forward and back. So side hung floats like this aren't really affected like that. But again, when you take a center hung float carburetor like this and you turn them sideways, now they're not affected so much by forward and back motion. But just because we were rebuilding this particular carburetor, I wanted you to see what's inside of a side hung float. It's the same things. In fact, it's the exact same needle and seat right on here. Same parts that came out of the other one go in here. It's a little bit different style float. This is actually one of the nitro fill floats that we were talking about with the superchargers. This one has one right here. I said I'd show you one a little bit later. This one has one. So we had white plastic ones. We had brass ones, and the brass ones, remember, implode when you're under high boost conditions with blow-through carburetors. And here's a nitro one, and these are not affected by boost from blow-through carburetors. So sometimes we'll change to those in these carburetors right here. But that's a side hung float right there. So we'll go ahead and put this on right here. Pop the gasket on again, kind of hold it in place, put it on there, take the float, drop it on there. Now we don't have any rear accelerator pump linkage, so we don't have to worry about that. I've already stuck the gaskets on these this time. Didn't forget to do that this time. Pop these on. Okay, we got that all nice and tight. So basically the carburetor is pretty well complete right now. We still have a few adjustments to do I want to show you here. Now that we put it back together, this accelerator pump linkage is way too loose. Sometimes they're way too tight, sometimes they're way too loose. Basically you just want to adjust it where there's about, a 5 to 15 thousandths gap in them. Everybody's got their own preference on these. But you do want just a slight amount of gap. This right here, man, that's 1/8 of an inch. What's going to happen is when you activate the linkage, it's barely moving it. We're hardly getting any movement right here because there's so much clearance. It should be starting from up here. So what we're going to do is lengthen this spring right here. We'll take a couple little wrenches right here, back it back off. We're going to lengthen this spring right here. It's getting a little tighter. Now what will happen if it's loose like that, if it's too loose, what would happen is you're not going to get the fuel squirt from the accelerator pump. So you're going to have an extreme lean condition. When you give it the gas, you wouldn't have got that squirt of fuel. It would have went real lean. Usually when you go lean like that, you get a lean pop where it spits back through the carburetor. It'll go pow, real loud. It scares the hell out of you when it goes because it'll blow a flame and everything because you get what they call a lean pop. It's quite fun when you got your face near the carburetor or something under the hood and the thing goes. It's usually a bang the back of your head on the hood and it wakes everybody up. It's no fun. So we can see right here there's just a little bit of play. That's about where I like to have them, somewhere right in there, maybe 5-10 thousandths worth of gap. Now watch the movement on here. Watch this lever come down. We're getting a little more push right there of movement. We can certainly come back in here like this and just give it just a cinch more, just a little bit where, there we are. It's almost zero. We got maybe a 2 or 3 thousandths gap right there. Some people like them on the tight side, some people like them on a loose side. Different carburetor tuners will tell you different things. If you look in most manuals, they tell you 5 to 15 thousandths right in there. But now we got a nice full travel right there. It's pushing it down pretty good, and we get a good squirt of fuel. All right, now we're going to look at the bottom side of this carburetor. It's the last couple of adjustments. We're almost done here. I'm going to flip it up like this so we can see what we're talking about here. Now we talked about on other carburetors in the past, on the HP series and on the Demon carburetors, where they had secondary adjusting screws on the top side. A lot of them have secondary adjusting screws down here. Some carburetors don't have them at all, period, but there is a little set screw right here, and that is for adjusting the secondaries. If we screw it in, what it'll do, if you watch right here, it'll just start to just crack open the secondaries right here. Oh, it's probably so minute you won't be able to see it. If I crank this open, though, it'll open these just a couple of thousandths. That's for adjusting the idle on like a large cubic inch motor where you're not passing enough air through here. You can actually open up the secondaries a little bit, pass a little bit more air, and recompensate for it. And that's why some carburetors with that adjustment on the top side have four-way idle circuits and things like that. There is one other thing here I want to show you. The idle circuits we've talked about before, if we look right inside here, there's a little teeny slot. You can barely see it because I've shut the idle way down. What I'm going to do is take the idle screw here, and I'm going to crank it up a little bit. And as we open it, you're going to notice that it's starting to expose the little slots inside there. That's the idle circuit with the air-fuel mixture screws right here. The adjusters here flow air and fuel through. It doesn't take much to get into that idle circuit right there, so it's kind of sensitive. So what I'm getting at is what we want to do is, now that we've taken the carburetor apart and we're putting it all back together, we just want to kind of set our idle. Watch this linkage right here. It's going to move as I tighten it up. You can see it coming up, coming up, coming up. That's good enough for a fast idle. We just crank the throttle plates open 15 thousandths or so, and that'll get us at a decent idle. We're just trying to set a baseline here so the car will fire up. One last thing I want to show you. This is the last thing on this carburetor right here. Some carburetors don't pass enough air. They got such a low vacuum signal and such a radical cam that they just don't pass enough air to idle. What we run into is, you got the idle cranked up all the way and it's idling too fast, but you're not passing enough air. Some carburetors have the throttle plates. What we do is we drill them out with little 16th inch drills, and I have one right here. This is an old beat up carburetor, but it'll show you right here that there are little teeny holes drilled in the throttle plates right here and right there. That just passes just enough air through just to help the idle be a little bit better on the motors like that. Some motors on radical motors where they have big cams and stuff, they need this right here. That's a common little trick to do. The thing you don't want to do is just say, I'm going to take an 1/8 inch drill or a 3/16 drill and start hogging big old holes in there, because once you go too big, you can't go back. You want to start off small. And keep in mind, the idle circuit is just a little teeny thin slit, and that's all that's supporting the motor for running. You go drilling big old holes in there, you've 5, 6, 8, 10 times the size of these idle circuit holes. You'll screw it all up, and it'll idle real lean, or you won't have a very good idle at all. So start off small, a little 16th inch drill it out there, put it on, see if you can adjust the idle. If it works good, great. If it doesn't, then just go up just the next size, a 1/64 of an inch, and try that. That should help it to idle a little bit better. All right, well, that pretty much wraps up a rebuild for a basic Holley. Now, mind you, you might run into little differences here and there between your Holley and this Holley here, but pretty much what we covered right here will cover all the double pumpers, pretty much all the vacuum secondaries, and pretty much any Holley in general. It's all about the same. They're all about the same design, and it's a simple rebuild. This carburetor is ready to hit the car and be back on the street running good again. All right, what we have here is a customer's car, typical small block Chevy. It's got an Edelbrock 600 on it right here, and I'm going to give you kind of the parameters and adjustments on this typical carburetor. We'll look on in here. This is a 600. We've already taken off the linkage because we're going to swap this carb out in just a minute here. I just wanted to show you some of the highlights of this carburetor. We do have some vacuum lines up front right here. This is the lower vacuum port right here, and the lower vacuum port, that's manifold vacuum. This would be like to activate the modulator valve on an automatic transmission. We have one over here which is ported vacuum. Some people call it timed vacuum. That right there would go to like a vacuum advance on a distributor in most cases. On the front right here, this one right here is a PCV valve. This is going right over here to the PCV valve, right in the valve cover right here. And on the back side, we have a hose right here that goes to the power brakes, and we're taking that right off the back side of the carburetor right here. Of course, some cars don't have power brakes, so you don't obviously need this, but most motors do need a PCV valve. I've talked about before that a lot of performance vehicles don't use vacuum advances on the distributors, and that's okay. If you're not using a vacuum advance, just put a good plug on there. And if you're not using a automatic transmission, you have a manual transmission or something like that, just plug this off, and you're good to go. All right, I'm going to show you this side of the carburetor right now. This is where the choke is, and of course right here there's an electric choke. We have 12-volt feed wire coming in here that comes in when the key gets turned on. This side's a ground wire right here. We have a vent hole right here that we have plugged off, or the person that owns this car has it plugged off. I want to show you something about vents though too, and not just vents, but vacuum ports or any ports like that want to plug off. This is a vent plug right here. This is what you want to use. We do see times where people use things like this. They take a piece of line and put a bolt in the end of it and stick that on there as a plug. That's not a really good thing to do. You're going to find ghost vacuum leaks and things like that, and the carburetor's never really going to have good idling qualities about it because you're going to have little vacuum leaks, things like that coming in here. If you got a vacuum line or a vent or something like that that you want to plug off, get the right plug for the right job, and you know, that ensures that it's done properly. Of course, we have the fuel line inlet right here. And while we're talking about chokes over here, I'm going to show you how to adjust this, because right now the motor's stone cold. And with the motor stone cold, we can see right here the choke plate is actually open. And we talked about chokes and how they work before, and I'll kind of refresh your memory here a little bit, that a cold engine needs more fuel. It doesn't burn efficiently when it's cold. So what we want to do is richen the air-fuel mixture up when the engine's cold. And all that does is mechanically close off this choke plate. Well, that's controlled by a spring right inside here. It's a flat wound spring that gets electricity when the key is turned on. While the electricity is going into that flat wound spring, it slowly heats it up and it turns the spring. As it expands, it turns the spring and pulls the choke off as the engine warms up. Right now we can see it's not set properly, so I'm going to show you how to set a choke properly. So with the engine cold, we've got to undo these screws right here. These just hold the choke plate or the choke adjuster in place. And if we look right here, I don't know if we can get a shot of this, it says lean right on here, right on the side of the plastic right here. It says lean with an arrow pointing counterclockwise. That means if we turn it this way, you can actually see the choke plate open right here. You can see the choke plate correspond to the movements I'm doing right here. Well, obviously, if we turn it this way, we let more air inside there. It leans the mixture out. We want to richen it. So basically, we want to close the air off when it's cold. So we're going to close it back this way until it just closes. You don't want to crank it because the thing will never open. When the engine's warm, this thing will barely be open and it's still going to be running rich. You don't want that. So what we're going to do is just turn this to where it just closes and just check it again right there. And once we get it right where we want it, just give it a cinch and that'll hold it right in place and the choke should be adjusted. That's primarily a simple choke adjustment right there, and that should help the engine start up good when it's cold. Okay, what I'm going to show you next here are the basic adjustments of this carburetor right here. We're going to start off here with the idle speed screw, then we're going to go to the air-fuel mixture screws right here, and these are what adjust the air-fuel mixture at an idle only. Okay, so we'll go ahead and start this puppy up here. Now, of course, we're going to adjust the idle here by this screw here. We can raise it. If we want to bring it down, we can drop it back down. That's a good idle right there. Now we're going to go in and adjust the air-fuel mixture screws. This one right here, what we do is we turn them in until we hear the idle drop. And back it back out. That's about good there. We do the same thing over here. That's about good right there. So what we're going to talk about here is what we just experienced there. You saw the air-fuel mixture screw go in here until the idle dropped. Once it hit a certain area there and the engine started to drop and almost fell off and stalled, we had to back it back out immediately. That's because we closed this air-fuel mixture screw off too far and it wasn't allowing enough air-fuel to get in to support an idle for this side of the engine. This one right here adjusts the driver's side of the motor. This one right here adjusts the passenger side of the motor. So that's why we ran this in until the idle dropped, and we started backing it out a little bit until we got the highest possible idle. We came over here and did the same things. Always screw it in first to close that needle and seat off to shut the fuel and air mixture off or cut down on it until you hear the engine start dropping. That's telling you that's not a sufficient amount to sustain an idle. Then we start backing it back out until we get the highest possible idle. Occasionally you'll get down so far the engine can't catch back up to itself. That's why I gave it just a little bit of throttle there to kind of help clear it back out. That's not uncommon. What you might run into sometimes, though, is some carburetors are so out of adjustment from the factory or right out of the box because they don't know exactly what size motor you're going to put it on or what camshaft you have or anything like that. So they just kind of do a basic set. They screw them in all the way and back them out about 1.5 to 2 turns and figure that'll sustain an idle. Sometimes you'll back them out so far the idle will actually go up quite a bit, and these only support at an idle. So if you bring the idle up too far, you need to come back over here and readjust the idle speed screw back down to keep it at a normal idle. Otherwise, if the throttle is up too far, these won't affect anymore because you're not on the idle circuits. Now you're actually in the throttle plates, and you've opened the throttle plates enough where you're drawing through the main jets. So you can only do it at an idle. And that's basically a basic adjustment of a simple carburetor like this. All right, now we're ready to remove this carburetor. I want to show you one thing first, though, just a simple little trick. When you're taking vacuum lines off, of course, this is pretty simple right here, and you already kind of know where they go. Some carburetors have 4, 5, 6 vacuum lines for smog devices and ported vacuum switches and things like that. What you want to do is mark these real good if you're not exactly sure where they go. And it's real simple. You know, some people just take a pen and a tape, just a Sharpie. They'll take a piece of tape and just put it around a vacuum line, like so, and then mark it A or B, and then put a corresponding A or B here. That works pretty good. Problem is, if the tape falls off or it gets smudged and you can't read it, it's hard to go back and find where that one went earlier. We can come here. I have these that I keep in the shop. These are just different colors of fingernail polish. I know I'm not a foo-foo guy and I don't wear fingernail polish. I just use these for marking vacuum lines. And it's real simple. You know, you can take a pink one like this, just take it off, just take a little smudge right here, put a little pink on the line right here, and put a little pink on the carburetor. And this stuff is acrylic. I mean, it's basically car paint. So what we can do is mark different colors for different ones, and then when we put them back together, we know where they go. So this one right here is blue. We can take a little blue. Just makes life easier. Put a little dab of blue on that, little dab of blue on the carburetor, and then let that dry. And when we go to remove this carburetor, you'll see these different color codes. When you put the other carburetor on, you'll know, oh yeah, well this one right here went to here, or this one right here went to here. Of course, we're going to do a carburetor change, so we won't be putting these in the same ports. But if you're just swapping out the carburetor or taking it apart, putting it together, like say to do a rebuild, that's an easy thing to do and help you find where to put the vacuum lines again. All right, so we're going to go ahead and remove this carburetor here. Simple procedure. We've already got the vacuum lines marked, so we would just pull those off. Pull off the PCV hose. Pull off the power brake line back here. Get that off. Boy, that's a tight one. Just remove the bolts here that hold it down, the nuts that hold the carburetor mounted down. So I'll take these off. Unplug the choke. Next, we just take the fuel line off. You want to be careful of the fuel line. Sometimes there's pressure still in here. You'll undo the fuel line and it might spray a little bit. So just be careful of your eyes as you're taking this off. If the engine's just been run recently, sometimes there'll still be fuel pressure inside there. Be prepared to put your, see, there we go, right there. That's a little fuel pressure in there, so just be easy with it. What we can do is take a rag. Just keep a rag handy. Pop it under here so you don't get fuel all over the place. Keep your thumb over. There we go. What we can do is take a plug. This just a little plugs it. Real simple little thing. Plug that off. Because there is fuel in this fuel line right here. If you lay it down, it might just start dripping out all over the place. So put that off to the side a little bit. Mind you, the carburetor is full of fuel, so you don't want to pick it off there and tilt it around or anything, or it will dump fuel all over the place. Also, make sure you account for every single nut and washer that comes off this carburetor. If you started off with 4 and you got 3, you better find it, because if it goes down the carburetor or down the intake manifold when we take this off, you're talking serious engine damage or a completely blown up motor. So make sure nothing is dropped in here and everything's accounted for. Always change this gasket when this comes off. Some people don't. I don't know if you can see it real good here, but there are indentations right here from this particular carburetor. We're changing to another type of carburetor, and it's going to have different vacuum runners and leeways underneath there where the vacuum lines pick up their vacuum signal from inside the plenum area. We go to put a different carburetor on, they might cross over each other and you get a small vacuum leak. It didn't seal. Gaskets are cheap. You're talking $4 or $5 for a carburetor gasket. It's not worth $4 or $5 worth of hassle when you get a vacuum leak trying to troubleshoot it out when you could have just threw a new gasket on and not had the problem in the first place. All right, the carburetor we're going to install on this customer's car here is a Holley design carburetor, but it's built by Quick Fuel Technology. This is a new and upcoming company. They're really putting a lot of effort into making some really killer carburetors. Let me kind of give you some highlights of this carburetor before we just stick it on and adjust it here. Give you some features of it. You can see they use the contoured body right here for better airflow. There's no choke horn. This is a serious performance carburetor, so there's no choke horn, there's no choke or anything like that on it. This is a 750 design right here. It's a double pumper. We can tell that because we have a accelerator pump on the front right here. And if we look on the back side, there's an accelerator pump right back here. So it's a mechanical secondary double pumper carburetor. Now, I've talked about it before that these aren't great street carburetors for some applications. Well, what you don't know about is this vehicle right here. He's got quite a high stall converter in the transmission, and he's got a manual valve body inside the transmission, and the rear end gears have been dropped quite a ways down to a 456 gear ratio. So this car right here is going to be a 0 to 60 leaper. It's really going to leap from 0 to 60. So he can afford to have a carburetor like this because of the stall speed of the transmission, and everything's going to be matched together to best utilize this type of carburetor right here. So let's look at some of the features. We talked about low idle air bleeds and goodies like that. Well, we look right down in here. This has four-way idles. It has screw-in air bleeds, both on the high side air bleeds and on the low side air bleeds. It's got down leg boosters. You can see them dropping down deeper inside the carburetor there for a higher vacuum signal. Just mixes the fuel out of the main jets at a different pressure level inside here. We have the vent tubes just right up here, just like any typical Holley design carburetor. Some of the features of this carburetor, though, that make it different than others, these are billet aluminum jet plates right here. And we've come over to the side right here. It has a CNC billet aluminum base plate. And what you don't see on this base plate right here are most carburetors have the throttle linkage just running through the base plate. These guys right here have Teflon bushings inside. And it's real common to get a brand new carburetor and take the linkage and you're able to shake it up and down a little bit, 10 or 15 thousandths, sometimes 20 thousandths, and that's normal. That's acceptable out of the box tolerances. This has none because it's Teflon bushinged, which is real nice. It makes for real smooth throttle action and no vacuum leaks whatsoever. It's a really strong base plate. We have our idle mixture screw right here. We come on back on this side right here. Of course, here's the secondary linkage on this side. And we talked about this before where we have adjustments for the secondary throttle plates where we can actually open them and close them to adjust for idles. This has one on the top side right here, which is pretty nice. If we can't get enough air on the inside by the idle adjustment on this side, we can actually crack open the secondary throttle plates just slightly to help solve idling problems. And of course, we have a dual feed inlet fuel line right here, and just a typical double pumper style dual feed inlet. And we come over here, and it has two vacuum lines over here on this side right here. One of these is for timed vacuum, for vacuum advance, and the other one is for manifold vacuum. The difference is these are plugged off because we're not going to use these. The distributor that we've set up now in this, we're not going to use the vacuum advance. We're just going to use the mechanical weights in it, so we're not going to use the vacuum advance at all. And being that this has a manual valve body inside the transmission, we're not using a modulator valve anymore, so we don't need the vacuum signal going to the transmission to help the second to third gear shift. We don't need that anymore. All right, so we're ready to drop this Quick Fuel Technology carb on here. We've got a clean gasket surface area, made sure that this is all clean. Starting with a fresh gasket, just drop it on. Make sure it sits flat and everything. I'm going to take this baby and drop it right on there. Take all the washers, drop those on. We take our wrench, give them a little secure. Never tighten down one side You want to go evenly. Don't tighten down one side too much. Just want to put a couple of pounds of pressure on that. Bottom this out here to where it just makes contact. Right there. Put a pound or two of pressure on that. Come over to this one here. Do the same thing. Same with this one back here. And once you've got a couple of pounds, then just kind of put a little more pressure on each one. You don't want to tighten one corner and then go to the other corner and tighten, or you'll warp that base plate. Just go little by little. Take your time, not in any hurry. We're not between rounds at a race or anything like that. And you only need to tighten these down to about, 12 to 15 pounds of pressure, and that's it, and you're done. That's all it takes right there. And of course, we hook up the fuel line. Nice new hose clamp on there. And the fuel line up. Give that a cinch. And then we're going to hook the PCV hose up to the PCV port on the back of the carburetor here. And of course we'd hook up the linkages, everything like that, and get all that hooked up. Just for time purposes, I'm not going to hook this up right now. I'm just going to show you the startup procedure and adjusting. All right, now we've got the carburetor on there, all the lines hooked up. There's one last thing we want to do before we're ready to start it. It's not real good on an engine just to crank it over. Right now, the bowls are empty. We just put a dry carburetor on. There's not a drop of gas in this thing. It's right out of the box. It's a good idea to prime a carburetor before you get ready to start it. A lot of people just pop it on there, they'll turn a key, run in and crank and crank and crank and crank as the fuel pump squirts a little fuel in there, because this is a mechanical fuel pump, so it only spurts every engine revolution. So sometimes it takes a little while to fill the float bowls up. If you have an electric fuel pump and it's a simple flip of the switch and it primes up the float bowls and you're ready to fire the thing up. Being that this is a mechanical fuel pump, we're going to fill the float bowls up just a little bit so we can get some fuel going in there and actually be able to get it started without having to dry crank the engine so much. So what we have is just a little teeny funnel right here. Let me show you where these go. These are the float bowl vents right here, just like on any typical Holley carburetor. There's one for the primaries, one for the secondaries. So we're just going to drop this little critter in here, like so. I'll take a rag, because you're definitely apt to spill some fuel here. And I've just taken just a soda can right here and cut it in half, and I put a little gasoline that we're using for this car in it. And we're just going to pour, a little bit of fuel in here, just to fill it up. Now you don't want to put too much. You want to put maybe, a half a cup of fuel maybe or so in each float bowl. The reason we're doing this is because to get this thing to fire, we need to be able to activate the throttle linkage. And here's the accelerator pump right here. When this gets pushed down, outside the squirters right here, there's a rear squirter and a front squirter. And we want to be able to see the fuel squirt out there to let us know that the engine will indeed fire. Just for fun, I can push this one down back here and you can see this squirter right here. It should be dry. Oh, there we go. There's a couple of spurts. There we go. There's a nice steady stream coming out of there. That's telling us this carburetor is primed and ready to go. So we're pretty much ready to fire this thing up and do the adjustments on it. All right, before we start this up, let me kind of give you a rundown of what we're going to do here as far as adjustments go. Now this carburetor has four-way idle circuits, meaning it's got an air fuel adjuster on the left side and an air fuel adjuster on the right side that works the primary side of the carburetor. Then we have an air fuel adjuster on the left side and an air fuel adjuster on the right side for the secondary part of the carburetor. So it's four-way idle circuit. And just like any other carburetor, what we're going to do is we're going to fire it up and adjust them inward until the idle drops a little bit. And that lets us know, okay, that's too far. Then we're going to back it back a little until we get the highest possible idle. Then we're going to go to the other side and do the same thing. Then we come back and do the same thing on the back side. Once we have that all adjusted and we've readjusted the idle back down to where it's a nice smooth idle, should be all set as far as the air fuel mixtures go. So go ahead and fire this up and see what we can do here. All right, the last adjustment we need to do here is the float bowl adjusting. And remember, we have the primary float right here and the secondary float bowl right here. Here's the needle and seat adjuster right here, and this is what adjusts the float level up or down. We have a sight plug on this side, both on a primary bowl and on a secondary bowl. And this is where the fuel level is regulated at right here, where we can actually see the fuel level. I'm going to open this here, and of course this carburetor is not fully adjusted. They come pretty adjusted out of the factory, but everything's got tolerance differences in them. So this right here, chances are it's probably not adjusted correctly. And actually, believe it or not, I hope it's not, so I can really show you here what we have going on. So we're going to open it up, and yep, we got fuel pouring. Oh, not bad. There's fuel pouring out. I don't know if you can see that. And that's just about where we want it. I prefer it down a little bit. The fuel level I like to see at the very bottom of the threads right here. And it was about, a 1/16 or so of an inch up. I'd like to see it just down a little bit. So we're going to put that back in there. Oh, wait, we'll put this on top here. Now, the fuel system has pressure in here from the fuel line up to the needle and seats. There's pressure sitting in here. There's no pressure inside the bowl, but there is at this needle and seat. So when I crack this open, it could spray a little fuel. So just be careful, watch your eyes. It very well could yeah, see the fuel coming out? You can see it dripping down right here. I don't know if you can catch that right there. That's because there is fuel pressure present inside there. So just be careful. We're going to lower the fuel level here. So we're going to screw this down just a little bit. Right there is about where we want it. We'll give that a cinch. And that's about the level we want right there. If we shake the car here, you can just see it right there, and that's about where we want it. We can double check this with the engine running. On an electric fuel pump, you just turn the fuel pumps on. This one is a mechanical fuel pump, so we actually have to start the engine and check this. But be careful of the fuel around here. Don't get it around open sparks or flame. You could have a fire and be barbecuing your car here. So we're going to go ahead and fire this up, and let's take a peek here. That looks real good. We didn't get fuel pouring out of there or anything like that. It's right at the very base of the threads. That's just about exactly where we want to be. Now we'd repeat the same thing on the back. Now of course if we didn't see any fuel inside there, if we open the port up right here and we didn't see any fuel, we'd want to raise that by turning the needle and seat adjuster right here counterclockwise, which would raise the float level, and we'd raise it until we saw fuel and then just stabilize it down where it's just at the bottom of the threads, and we would be done. And that's adjusting the float levels. It's as simple as that. All right, well, we've covered a lot about performance carburetors. I hope you learned a lot. You can put some of this to some good use for your own hot rods.